this is another great problem that helps us review that order matters when we name a figure in the order that we connect them, and that what I guess makes a parallelogram. So just to review, a parallelogram has opposite sides parallel. And on the coordinate plane, we know that parallel slopes are equal. So for two lines to be parallel, we know that their slopes will have the same value. They'll have the same rise over run. So if I go put these points, I'm going to go put point A here. It's my origin, 0, 0. Point B is 7, 1. So I'm going to go over 7 and up 1. And then I have point D is 3, 4. So if I go over 3 and up 4, I get my point D. Okay, the first question says, or the first part of this question says, find point C so that A, B, C, D makes a parallelogram. So in other words, I'm going to go from A to B, then to C, then back to D. And then D will come back to A. So looking at this, I know that I must have a point somewhere over in here, because the relationship from A to D is that D is to the right of A. And so I know that to be a parallelogram, to have the same slope, that same thing's going to have to happen. So in looking at this, and get that point B back, or that point D back on here. Okay, so we have point D was 3, 4. All right, I need to ask myself, what is the slope between A and D? Because that is the slope that I'm going to have to repeat from B to C. So from A to D, the slope is up 4 over 3. So my rise over my run, it's up 4 over 3. So from B, I need to go up 4 and over 3. So if I go up 4, okay, B is already at 7, 1. So its height is at 1. I need to go up 4. So I know that it's going to add 4 more to that, so it's going to end at a height of 5. But then I also know that I need to go to the right 3. So right now I'm at 7. If I add 3 to that, I'll go to 10. So up 4 over 3 is going to get me at the point 10, 5. So B to C, be right there. And then I know I can verify that the slope from A to B and D to C would be the same. So the slope from A to B, well, to go from A to B, I'm going to go up 1, then I'm going to go over 7. So my slope of A to B is up 1 and over 7. My slope of D to C is also up 1 and over 7. Since these two have the same slope, I also know that AB is parallel to DC. So we've just proven that those opposite sides are parallel. Now we have the different case. What happens when we want to change that order, when we want this to be A, B, D, C instead? All right, this time for this case, we are going to connect A to B to D and then to a C point. So we know that that C point must be somewhere over in this area. We need to figure out what that point is, and we're going to have to do the same thing we did in the last problem. We're going to use our slopes. So I know that AB, the slope of AB, has to be the same as the slope of DC. So I'm going to go ahead and I'm going to take a look at what is the slope of AB. Well, we calculated this on the last problem. We said that the rise was 1 and the run was 7. I went up 1 over 7. So I need DC to also go up 1 over 7. And in this case, we need to think about reversing that slope to some extent, because we are going to go to the left instead of to the right. So from D, I can rewrite this slope right here as -1 over -7. And that would get me the same answer of positive 1/7, because to divide a negative by a negative, we get a positive. So from D, I'm going to go down 1 and to the left 7. And I get this point right here, letter C. And that point at letter C, so C in this case is going to be -4, 3. And that's going to get me a parallelogram ABDC instead this time. And I can go ahead and verify that the slope of DB is equal to the slope of CA. So let's go ahead and verify that. From D to B, it looks like I go down 3 and to the right 4. Well, from C to A, I also go down 3 and to the right 4. So since these two slopes are the same, I know that DB is parallel to CA. And I purposefully constructed that AB would be parallel to CD. So therefore I know that it's a parallelogram.